Welcome back, grade 8 science class. Today what we're going to learn is just basically an overview of the optics unit so far. I know it's been several weeks since we learned this stuff, so a review is needed. Now, I'm going to try to help you out here. In the upper left-hand corner, you can see this orange box here where it lists the chapter, section, and page numbers for the material that we're covering. So if you have any questions or you need to look up a term or you need to refresh your memory on some concept that we've covered or are covering, this is a section of the textbook that you can do it at. All right. So the first section we looked at is what is light made up of? So the question here is it a particle, like a solid marble flying through the air, or is it like a wave, like an ocean wave flowing through the air? Well, we can do some experiments. We can set up a particle detector and shine some light on it. And the particle detector will count the number of light particles hitting it. So obviously, light's a particle. And you know what? Albert Einstein would agree with you. He did a very, very famous experiment that showed something called the photoelectric effect. Now, you do not need to understand this experiment, but what he discovered is that light travels in these specific packages or quantities or quantum of energy. So you can't just get any amount of energy you want out of light. They travel in these packages or quantum of energy. So this is light behaving like a particle. And pro tip, this is where we get the term quantum and quantum mechanics from. There's another famous experiment called the double slit experiment. So if you bounce light into each other, you can actually see this sort of interference pattern happening. And this is an example of light acting like a wave. Now, this is exactly like dropping two pebbles into calm water. If you drop a pebble into water, it'll start making a wave. And where those waves bump into each other, you see this sort of weird interference pattern happening. That's exactly the same thing that happens when you bump two light waves into each other. So obviously, light also acts like a wave. So what is the answer to this question? Well, light is both a particle and a wave, and it's both at the exact same time, which is crazy. It just depends on how or what you're measuring about the light. So this is a classic physics problem called the particle wave duality of light. And it just shows you when you're talking about physics of like really, really small stuff, like it starts to get super, super weird and interesting and awesome. So a couple little terms here. So when we talk about light as a particle, we talk about it as a photon. And when we talk about it as a wave, we talk about it as an electromagnetic wave. For the sake of this course, we're mostly only looking at light as a wave. So this is where we're going to spend most of our time. If you want to delve deeper into this topic, we watched a couple YouTube videos in class. They're going to be linked here. This is the first one, and Bozeman Science is the second one. You can watch these videos in the attached PowerPoint slide, which will be attached to the Google Classroom post. Our second topic, we talked about the parts of a wave. So here, this is a bit of a review in that we talked about some parts of the wave when we talked about ocean currents and ocean waves. So again, this is section 4.2 in your textbook. Note the orange box in the upper left-hand corner. So some of this was review. So the crest is the top of the wave, the trough is the bottom of the wave, and the wavelength is just one full cycle of the wave. Or you can measure from the crest to the crest or the trough to the trough. It's just the length of a repeating wave. The new terms that we talked about, one is amplitude. This is the height of the wave crest or the depth of the wave trough measured from its resting position. So think about the slinky lab that we did. So when you're holding your slinky at rest, so not moving, it just forms a straight line, like the dotted line in our diagram there. And then when you started making a wave, the amplitude of your wave is the measurement from that resting position to the top of the crest or to the bottom of the trough. The next term that we talked about is frequency. So frequency is the number of repetitive motions or oscillations or cycles that occur in a given amount of time. Or you can think about this as the number of wavelengths that pass by you in 1 second. Now, this is easy to calculate. We just take the number of wavelengths or cycles in your wave and you divide it by the amount of time that's gone by in seconds. So the units of frequency, they're measured in cycles per second or wavelengths per second. And the units here we use are hertz, HZ for short. Now here's a couple examples of waves. Remember, when we talk about frequency, we're talking about how often something is happening in common language. So a high frequency wave means that there's lots of waves happening in a short amount of time. So you can see here in our first example here, there's lots and lots of waves in a short amount of time, and they've got short wavelengths. Low frequency means the waves aren't happening as often, so there are only a few waves in that same amount of time. So here in our second example, we've got only a couple waves in that same amount of time, and that makes their wavelengths much longer. Our next section, we talked about color theory. This is section 4.3. And what we really talked about is what about a wave of red light makes it red as opposed to purple or blue or green? What makes the different waves of light different colors? And it's actually their wavelengths. So purple or violet has a wavelength of 400 nanometers. That's the top one right here. And the bottom wave length of light, red, has 665 nanometers. So different colors of light have different wavelengths of their light wave. And to sort of illustrate this difference, we watched this YouTube video of this guitar, and you can watch this again in your slides. But if you take a look at the different strings here, each of these is playing a note with a little wave in there, but you can see that the waves are very different. So this wave, right, the low notes have a very long wavelength and low frequency, and the clear string here plays a higher note, and its wavelengths are much shorter and its frequency is much higher. And this is just to illustrate that if a wave has different wavelengths and different frequencies, it's going to have different properties. So in this case, the different waves create different notes of the guitar, and in the electromagnetic spectrum, in light, the different wavelengths of light create different colors. Just as illustrated here again. So different wavelengths of light mean different colors. All right, ladies and gentlemen. So for today, I want you to review the key terms and concepts that we covered in this review. If there's anything you need to refresh your memory on, go back into that section of the textbook and let it read to you, or do a little bit of studying on your own and figure that sort of stuff out. Now, once you feel confident in the material, quiz yourself using the Google form that is attached to the Google Classroom post. So go back to Google Classroom, go to the Google Classroom post for this lesson. The Google form will be attached to the bottom. Quiz yourself, see how well you did. And lastly, join the YouTube live stream, and we're going to try to play Kahoot using YouTube Live. Now, I was informed that your Google accounts won't allow you to use Office Meet. So we can't, that plan has to be scrapped. We're going to try to use YouTube Live for the exact same thing. So if you have questions or comments, you can do so in the chat on YouTube Live. If YouTube Live doesn't work for the Kahoot, I'm just going to post the Kahoot code or ID onto Google Classroom, and we'll just play it that way. So again, that's all at the same time, 1 p.m. On the day of the lesson today. So Thursday, April 9th, 1 p.m. All right, you know what to do. Get at her. Good luck and enjoy.